data pipelines. So the stage is yours.
Thank you. If it's okay with everyone, I will stand behind the podium. I'm not a highly energy device like our previous presenters. And also I like the speaker a lot. So this talk is about the recent work we did together in collaboration with Euronymous Academy of Data Science, which is a very important strategic partnership for us. Here we propose a reference architecture for configurable big data pipelines. I would like to introduce a co-author of this reference architecture, Professor William Young, to tell a little bit about Euronymous Academy of Data Science. Sorry for that. I don't know the perfect distance. How about this? Good? Yeah? Okay, I think it's good. Yep.
So actually I insisted that I would say a little bit more about JETS. So I will say a little bit more about it. So JETS is a collaboration between two universities, Tilburg University, where I'm originating from, and the Technical University of Eindhoven. And in particular, we are located in Zetterbosch. And for those of you who don't know where the Netherlands are, I have this chart. In fact, I use it in the US to say, listen, we are somewhere here, so you have an idea. So here is still working as Eindhoven. Eindhoven is, of course, the premises of Philips. We're working with these guys quite intensively. So what I wanted to say today with you very quickly is what we are doing currently is we're setting up a new group, and I'm looking for staff and students. So this is why I'm here. So in fact what we are doing is one of the reasons I'm standing here now. So so we're combining groups of Eindhoven and of Tilburg. So in Tilburg we have a small but quite successful team, at least in the past, working on service engineering and service-oriented computing. So Professor Michael Mazoglu, you may know him, is spearheading that one. We're also working with the team of Will van der Haast, as long as Will is still there, of course, because he will be moving away to Germany. And we are combining those teams together to set up a new team that will combine data technology and service technology. And in fact, I just wanted to entertain you a little bit on this afternoon and explain to you why we have chosen for Jeroen Bosch. I mean, why we have chosen this name, JETS. So you may wonder. So in fact, Jeroen Bosch is not his real name. So who knows what his real name was? I would be surprised, but you never know. His real name was Jeroen van Aachen. So he's originally from Aachen, which is quite coincidental because one of our main principal investigators will move, in fact, to Aachen. And he changed his name because of marketing reasons. So because he was living in Zetterbosch, he said, okay, listen, because all people will know when things are from Bosch, he changed his name. So why did we choose for the name? We chose for the name, point one, because of the municipality. They would pay us handsomely if we would use that name and subsidize us, which is good. And also because I think it's a nice metaphor. So in Zetterbosch, we're combining data science with innovation and entrepreneurship. And in order to be, so we need to be creative. So this is why we've chosen for that name. And what we want to do is we want to look at the integration of service and big data and cloud technologies. And we're starting up a team. This team will do fundamental research on service and data engineering and apply it in various sectors. And we have mentioned a couple of those here on this slide. We want you, so this is, I'm standing in front of you. I'm here, of course, to enjoy the summer school and enjoy all of you guys. But I wanted to stress here is we're looking for PhD students, postdocs and lecturers to complement our team. And so please spread out the word if you know, perhaps to know some people who are interested to come over and live in the Netherlands and be active with us, and set up, and build up this team. You're more than happy to join us. Also, we are looking for PhD students working in these areas. Yep.
And you pay how much?
Not as good as German universities, I'm afraid.
That's what would be. And it always rains there, right?
But it's nice. It's nice to be there. So also I want to announce a symposium and invite you for it. This is really the last slide, which we'll organize together with Philips. So Philips is for us one of our strategic partners. We have more strategic partners like TomTom. We're also working very closely together with Booking and Elasticsearch and Tesla. So these will be the sponsors and of course also speakers on our today seminar. And I think you should move on.
You don't want to explain what this is?
Huh?
No, that's okay. That's okay. All right. So yeah, back to yes. Just a little bit of introduction. Coincidentally, I I graduated from summer school, defended my thesis here exactly 1 year ago from today, like on this day. This is from IMSA, a program put together by many of the professors here, and of course, not with us, late Professor Christopher Nicolau. So straight away after doing that master, I started with Philips Lighting as a researcher, as a scientist, specializing in data engineering. So typically day to day, I work with distributed systems to create big data pipelines in the domain of Internet of Things, and implement machine learning algorithms and data mining algorithms that my colleagues come up with. So a long time ago, a marketing commentator compared data to crude oil, and I really like that comparison because in hindsight, data is really like crude oil. It could be transformed into very valuable commodity, but you really need to do that yourself. And for me, data pipeline are the refineries that transforms these crude oil or like raw data into valuable commodity in an efficient manner. So what is a data pipeline? Well, traditionally, data pipeline was explained as a series of connected tasks where one task is dependent on the other next task. If you look like into the recent published use cases of data pipeline, what you will see is that it typically leverages multiple technologies, and this is done because we want to meet certain design goals. And if you go to any internet companies, you will find quite a few of these data pipelines lying around. So Netflix uses data pipeline to bring you movie recommendation, right? And Facebook, Twitter, they all use data pipelines in the backend to bring you different recommendations. But why is data pipeline of relevance to Philips Lighting? Something like you wouldn't really connect these two dots together with. We are a very traditional business model. We have been like the market leader for global lighting manufacturing for about 125 years or something. But what you may not know is also we're number one in connected lighting, and with any connected system that produces a lot of data. And these data can transform and provide new services in many areas. For instance, building, retail, stadiums, cities. And with this data, we can enable really obvious use cases like maintenance and so on. But also there are some hidden use cases that we can enable. So one example of that is like analyzing shopping traffic behavior, right? But this is really something that was not so obvious to us at first. At first, what was the solution we were going for is rather using interpositioning to provide users with, or helping them find new products. We have that installed in Carrefour in France, I know in Media Market, quite a few of these actually. So because of that, we choose to further investigate this topic together with Professor William Yan and IAPS. And the main research question was what are the components and data flow for a reference architecture of a big data pipeline. And this talk is really like, I'm really trying to work toward it. I really don't know what it is, and even in this presentation you will see that these are like really proposed concepts. I would really appreciate if you guys like just raise your hand and give me the feedback. We could really use that. Right, Professor? Yes? Yes. Okay. So, a reference architecture, right? In software, reference architecture defines the division of functionalities and data flow in between components. That's just what we read in literature. It's supposed to provide us like a high-level abstraction to facilitate concrete architectures, and is typically driven off reference models and architectural patterns. I am really short in time, okay, to fly through these. So also, it's a little tricky to put together a reference architecture that's in harmony with the context and goal and so forth. And that's because it's an abstraction. So we also went through literature to find this proposed multi-dimensional space where they go through different dimensions, so to speak, to analyze whether reference architecture is in harmony with the context and design goals. So what we wanted to do in our research, and what we did in our research, is several data pipelines, studied them, and then we also built a use case for a data pipeline that we open sourced. And we put this together, the experience behind that, and this study to get a few architectural patterns that was appearing in these data pipelines. Together with the multidimensional space I just showed in the last slide, we use this reference, we proposed a reference architecture and use that to validate whether this is congruent or not, or whether this is in harmony or not. So one of the use cases we studied was from PayPal, who has a carrier payment service. Carrier payment is just like it enables your mobile phone to be used like a credit card. So what they do is bring data from many platforms using microservices ingestions. I don't have the time to really go really deep into that, but what they do is bring data from any platform and push it to Kafka, message bus. From that, they do some really simple pre-processing, sort it out, and push it to a distributed database called Hive. And that sort of acts like a platform for their data scientists to do fraud detection. So that's one of the use cases we studied. We studied another one where they built pervasive sensor data pipeline, and the pattern is somewhat similar. Bring data in, push it sort of like into a buffer, and then get a distributed data processing engine, like you have Flink there from TU Berlin, or from UC Berkeley Apache Spark, which is rather an open source project now, and use different data analytics tool on top of that to provide insights into different systems, right? We also studied another one from Groupon, where they have this collection method where they collect and clean and standardize their data into a canonical format and push it into two separate sources. And then they have a more complex data processing pipeline to take that and drive insight. So after this, we also built one of these data pipelines to do benchmarking for different Dutch banks and their customer service in Twitter. So what we had was processes to collect tweet feeds, and we put them into local storage. We cleaned our tweets, we used different services to actually translate it and do sentiment analysis, because a lot of the tweets were in Dutch. So after that, we put that into HDFS and load it into another table in Hive, so other components can connect to it. We also had a controller component to control all the execution of these tasks. And yeah, so this Airflow is something you can think of like a workflow for distributed data pipeline tasks. So yeah, after analyzing these few use cases, we found a few patterns that was suggested. Well, in the use case I proposed, I found more anti-patterns. But yeah, so here are a few of them. I don't have the time to go through all of them. I'll just mention a few. So PubSub seems to be very common in all the data pipelines in the big data field, where you collect the data and push it into a queue and get another data processing engine on the other side to pick it up. Controller is something that's not so common, but I found it a really good idea to have sort of, I mean, instead of using something like CronTab to just schedule your task, have a professional system to take care of that. Also does logging and monitoring is nice. Also something we really want to do in our data pipelines that we implement in future is to have single point of configuration. So the pipeline I just showed you, we built, and also most of the pipelines we find in practice. What happens is that all the configuration node points are attached right to the task. And what we recently find helpful is that if you want to administrate these pipelines in future, when they go into production, like on a cloud solution, it's easier if everything is just at a single point and I can configure it, and the pipeline administrators are more efficient that way. So with that, we proposed this reference architecture for now. You have the data source, which is like external to the pipeline, and you can have a streaming source, or you can have a stationary source where you either get data pushed to you or you get data pulled to you, right? And the idea of the pipeline is that, okay, you derive some insight, transform it to value, and push it to a data store. So we have two separate components, just the core layer and the management layer. In the core layer, first you have a data collection service, which is supposed to pull or push the data based on the type of source it is. And then on the other side, we have the data processing service, which will transform the data that was collected by the data collection service and push it to the data store. In between, following up with the pub/sub mechanism we found so popular, we put a data queue, which will basically act like a buffer, something like Kafka, right? Like between these two components and make it asynchronous. Within the data processing service, you have three subcomponents. You have the consumer, which will pick up the data, relevant data that has not been processed yet from the data queue, pass it to the processing engine, and output driver should have all the connections ready to the data store that you want to push the data to. On the management side, we want, right now, we find it very important to take care of two things. One is the configuration, and the second thing is execution. So we want to have something like a metadata service where all the configuration parameters for the data pipeline is stored. So the data collection service stores things like, okay, how often should I execute, where are my end nodes, and things like these, right? And then with that, you have a configuration service which sort of provides like a UI for the data pipeline administrator to easily reconfigure these parameters. On the execution side, you have we find it a good idea to implement a controller service, and this controller service basically coordinates the task in the distributed environment. Yep, and together with that, a monitoring service is again the interface for the data pipeline administrator to have sort of an idea about what's going on in the data pipelines that are in production. And also, it can raise alarm and do these sort of things when it requires really intervention, right? Like, so if you're trying to execute multiple times and you're failing, then you really need attention. That's the component that's going to do that for you. I think I'm pretty good with time now. So after we put these puzzles together, what we did was we used that multi-dimensional space and put different values for each of the questions they ask us in that framework. So, for instance, the first question they ask you in interrogative questions, because apparently it's more intuitive. Well, yeah. So, why did we do this? Well, we wanted to basically do some sort of facilitation for concrete architectures, right? So the goal was not really to standardize or anything. We wanted to be used with multiple organizations. So I have a friend in TomTom who also feels that, okay, we will get our engineers to implement some of our data pipelines in this architecture and see how that goes. Right. Don't want to go through all of these, but the point is that once we put these values according to this research and this framework, this aligns with this type 5 variant that they proposed, which is really like a preliminary, premature reference architecture where the main goal is really to inspire more research in this domain. So, in conclusion, right, just like you said that we didn't really have time to do more use cases. We just did 3 and did 1 experiment of our own, and I know I have seen a lot more publications recently on data pipeline use cases, and we could quite easily bump that number up and observe more architectural patterns that are happening in the data pipeline. And also the validation was quite theoretical, right? Like I could not really demo you anything, and I kind of hate that. But hopefully within the next 3 to 6 months, we get a practical implementation that I'm allowed to show you. And right, so that wraps it up on time, and just like to get some feedbacks from you guys.
Okay, thank you. Comments, questions?
I know from some companies who also work on reference architectures for their, let's say, analytics work, what they want to do with the company. And I would say, as far as I know, I would say they look at similar questions, but then at the end they define a kind of reference architecture consisting on concrete modules. So they say, take Spark or take Flink, but we will select for you. We will provide, let's say, a fixed reference architecture, and then you plug in whatever you want to do in that architecture. So they fix much more, they make it more concrete as you are doing. And now my question is, why or is Philips doing it similar, or do they stay at that very abstract reference architecture?
Right, if we want to collaborate with YAPs, then it's easier to go into an abstraction level,
of course,
right? Because then they have like smart manufacturing that's really high on their agenda, but smart manufacturing is not so high on our agenda. But when we really come down to a concrete solution, we would not go with Flink. Nothing against Flink, I like its real-time processing, but
I was not asking for or against Flink, just whether you in your company will basically pre-select some of those components.
Exactly.
Make the architecture more concrete, right?
Right, so in our company, in practice, or in our team confluence pages and etc., we will not go with the reference architecture, but like this is the components we use indeed. But this is just for the research collaboration part.
Okay.
And also it's impossible because we don't really have developers with huge experience with Flink, but more experience on the Spark side. So even if I wanted to work that way, it's just not feasible to do.
Perhaps you said it in the very beginning, but I'm not really sure what are the key requirements that you are trying to achieve with the architecture. But when I saw the picture, and it was very agnostic in a sense.
Mm-hmm.
Right? You can do everything with it or nothing. So usually I would start from saying, okay, we want to do data processing pipeline for big data, and we have
I have those points in mind, but like
three scenarios in mind.
Yeah.
And then I would like to see, then the architecture tells the story, because the components derive from the features that you want to support.
Yeah. I realized that I had 15 minutes, so I really wanted to rush through and just had 2 minutes left after that. So the use cases I had, with that I actually had the story why they built it, what was the reason for this to be architectured like this, but I couldn't really cover it with respect to time.
Yeah. So the use cases were examples,
Right.
And then, which of these use cases, I guess there are 3, 4 features where you say, we want to support these, we want to become the killer pipeline for this and this and this.
Right. So that was I also attached with the story. For instance, I could have, if I had time, tell them like 3 or 4 key requirements people had when they wanted to design their data pipeline architecture. One of the story, for instance, was they wanted automatic retries. If there is a failure, they don't want to have administrative intervention. They really want self-management capabilities. So there are these capabilities attached with each of the story, but yeah, it's just a little too much for the time thing today. But yes, I would imagine, I mean, if somebody explained it to me like this, it's not really that understandable unless you're really in context. So, yeah.
Okay, thank you again. And the final talk in this session is given by Syed. to Stuttgart.